Greetings. Welcome to the floor of my workshop. I have here another project I've been working on. Surprise, surprise. There always seems to be a new squirrel running around to grab my attention. The contraption that you're looking at here in front of me, the end goal with this is to turn this into a electrically driven, remotely controlled lawnmower. Now, I did not build this from the ground up. The major components were primarily recycled, repurposed, reused, upcycled, whatever fancy term you want to use. This was previously a lawnmower from like the late 1980s, early 1990s that eventually I used it for a while, and then the engine stopped running, parked it, and set it out of the way. And for the most part it was junk at that point in time, but being the person that I am, I'm not just going to throw it away just to throw something away. So the base of this my lawnmower here, or what I'm working on, that is, this steel structure is the base of that lawnmower. This is the base. Out back would be a third wheel, the caster wheel. So we have the two drive wheels, a caster wheel. In the center here sat an engine, and then each wheel, there used to sit a hydraulic drive right here. And then each wheel was driven independently through two independent hydraulic drives, a left and a right. The operator sat up on top, and they would straddle two levers. There'd be a right lever and a left lever. You work them back and forth, and that would be your forward and reverse movement for each wheel. The mower deck sat out in front, and then it's a pretty nice, handy little lawnmower. Zero turn of its time. So that's kind of where this project started at, and that's the main component, is this heavy steel base. What I'm using to propel the lawnmower here are out of a couple electric motors out of a real old school wheelchair, electric wheelchair. One's so old that it didn't have your standard solid state electronic controller. It still used relays to control the speed and direction of the motors here. These motors are 24 volt DC. That's basically all the information I have on them. I can look up the name on the side, but I don't get much information. So I've had to do some testing, or do some small tests on the motors to kind of find some more information or determine information about them. The 3 tests I've done, one, it's a blocked rotor or locked rotor test. You basically lock the output shaft so you can determine the maximum current that the motor is capable of. I did a no load maximum RPM, determine what the maximum RPM was, and then I also, kind of along with that locked rotor test, I found out what the maximum torque. Made a quick test, nothing scientific, but kind of determined what the maximum output torque of this gear motor was. I'll move you in a little bit here. Motor is 24 volt DC, I said that already. The battery that I'm using is a 36 volt battery pack. Normally you wouldn't run 24 volt DC motor with 36 volts, but you can do it. You can harm the motor if you're not careful. As long as I'm not running this so hard that I'm running at that max lock, where I've slowed down the speed of the motor so much that I'm drawing too much current, I should be fine. If I'm running at 50% duty cycle on my motor controller, the effective voltage at the motor is only 18 volts, so I'm within that 24 volt range. We just won't tell the motors that I'm running a 36 volt system. Batteries are lithium iron phosphate chemistry. They're in here. I need to still build the attachment point for them, and I need to come up with a low voltage disconnect. These do not have any sort of battery management system on them as of right now. If I was going to do anything, it'd be some sort of homemade setup. So I think right now it's gonna look more like just a low voltage disconnect instead of a cell by cell monitoring solution. The controller I'm going to use, I don't have it handy right now, but it's dual drive, so it can run both of these motors off of the one module. It is set up to accept a RC, so remote control input, which is kind of handy. It has that capability to know when I'm commanding a left or a right turn. It'll be able to command that particular motor. The maximum continuous current output of the driver is 30 amps. So I have to be careful with that, because I know that these can draw 60 amps out of a 36 volt battery, and I want to stay away from that. 30 amps may be sufficient to propel this, but I don't know that for sure yet. My quick calculations I did, and having to dust off some cobwebs off my physics book in order to kind of get an idea of even if these motors will work. With a heavy frame like this, the output of the motor, the necessary output from the motor is dependent on the overall mass of my power unit here. And some quick calculations said that it should work. I don't know. We're going to find that out. So that's to be determined yet, I suppose. And with that motor controller, I hope I'm staying away from the 30 amps. Two drive wheels at least splits that necessary power element between the two motors, which means I don't need a huge motor. Oh, what else here? So originally these were a chain drive, and I kept that for now. I added some plates here and a jack shaft to get the motor output up. And then these are a gear motor, so they already have some gear reduction on them. I have done some further gear reduction to the wheels here through the chain drive. Oh, what else did I have to say here? So I can do a quick runoff of the power unit as to what I've got so far. Actually, for my test, I have set up a golf cart controller, and that, I don't know, I think the max current on that is like 300 amps. So I'm reasonably sure I'm not going to damage that. If you look back a couple of videos, I was discussing a motor controller that I had damaged, and I had 60 amp maximum or continuous output drivers on it. That was meant for this project. So now I'm down to at least getting a proof of concept before I decide if I'm going to get a new motor controller, or if these motors just are not sufficient for moving both power unit and with the mower deck on it. That's not talking about the motor that has to run the mower deck. That's a separate item. I talked about, so most I like about this is it's made out of metal. I can repair metal. The downside is that the output power of the motor it's a relationship. The need for it is in relationship to the mass of the unit here. If you look at a lot of what's coming out today for electric lawnmowers, ride-on lawnmowers as well, is that they're made out of plastic, and there's a reason for that, and that's so the power of the motor does not have to be so large, and that's one side effect of having a metal base. But I'll pull you in here and then I'll run the motor off. You can see the wheels turn, or at least one wheel here I have it jacked up so it doesn't try to move around, because with my golf cart controller I only get one direction. I don't get a bi-directional movement. Here we are moved in closer so you can see the motor and the jack shaft and then the wheel and the chain drive. We have our motor here. Down here is the output from the motor. This is the chain that connects the jack shaft, or to transfer that power through the jack shaft. Outer bearing, inner bearing. You can see that the shaft is not square to the frame here. That happened. I was not the best at getting my holes lined up, but these bearings are they're self-aligning, and they allow for some variation in their alignment, that they may not be perfectly straight on, I suppose would be a good term. The chain also gives a little bit of flex to it that I'm not too concerned about it. If I wanted it to be perfect, the best thing to do would probably have been to take a piece of square tubing, make my jack shaft inside the square tubing, and then mount the tubing to the outside here with the shaft sticking in. But I did not do that, and I might do that in the future. But then here's the chain that will drive the wheel. And I'll run that real quick. It's just on a potentiometer back to the motor controller. Just like that. It's a little bit noisy, but it's also what comes with a chain drive, is you get some of that noise. I can't say if I would change it or not. There are some things that need to be repaired. There's a idler gear here. It's a little sloppy. The shaft has actually been worn down because it was not maintained over its lifetime. That could be part of some of the noise, or it's just how chain drives are, is they make some noise. That's all I have to talk about today with regard to this project. Mowing season is coming up, so I have to get a move on. I gotta put my rear caster wheel on. I have a remote control on order, and I have to hook up my motor controller, but then I should be able to run it around and maybe get some video of that, and at least confirm if my motors are going to work. Maybe get some current measurements, and maybe do some tests to find out how much load I can actually put on it, see if it can push around the mower deck that was originally made for this. If you watched this far, consider subscribing to my channel. Go ahead and like the video, and if you think someone else might find this interesting, share it with them. Thanks for watching.